Hi, my name's Adam Backman. I work for a company called White Star Software. We do training, consulting, and we have a monitoring service and a free monitoring tool called ProTop. So I encourage you to go to our website and take a look and download it. And if you have any questions as I'm going along, please feel free to stop me and we'll go from there. What I'm going to talk about today is about performance lies. And the problem is all the time that we do these performance tuning assignments, we go out to sites and we hear the same exact lies from the DBA, from the network administrator, from the application people, from the users, all the different things that we hear. We also hear a bunch of lies from hardware vendors. Oh, you should buy the most cores you can possibly get in the box because you need all those cores. And the answer to that is probably not. And most likely not, because more cores equals more overhead. And you don't need that overhead. So if you can get fewer cores and faster cores, you're going to be better off. But we'll talk about that as we go through. I'll talk about the components of performance, because you have to know where everything is and what all the parts of the puzzle are before you can start building it. We'll talk about OpenEdge, the operating system. Then I'll do a few case studies of performance problems that we've had to solve or scenarios that we've looked at. And if you have anything that you want to bring up, we'll talk about those as well. And then we'll talk about things that we should avoid, worst practices. And those are usually found through the school of hard knocks. You do it once because it sounds like a good idea until it doesn't work. Somebody was talking about a client who had moved to this brand new SAN, and it was all solid state inside there, and they said it's going to be faster and everything like that. They did everything right, except they hooked it through the same virtual I/O server as they used for every other one, and it only had 8 gigs of RAM and 1 CPU. And so everything was using this one box, and right when they added this next data store to it, it actually flooded the cache of that machine, and it blew everything up. So their fast machine, they couldn't even ever get to it because the machine before it wouldn't let the I/O through. So it's important to understand where everything is and what all the parts are. The biggest thing that people try to do is they try to buy a bigger hammer. I'm going to buy the biggest, baddest machine that I can go out there. And that's generally not a good idea. The biggest component of performance is the application. And I can make good applications great, but I can't make crummy applications great. And they're going to always be bad. There's always going to be some concern that we have, and we have to become smarter when the application isn't performing as we'd like it to, and we don't have the bandwidth to go out there and change the application code. Then we need to change how we're using the application to make it most efficient for the most users. The network is fine. The network's at 10% utilization. No, it's not. It's at 100% utilization 10% of the time. So what these network admins do is they measure over large chunks of time. And they say, oh, we only have this much bandwidth that we're using. But if they use smaller samples, they'll all of a sudden see that the network is actually flooded in interim periods. And that's why they see this sporadic performance. So the network probably isn't fine. And on our monitoring tool, we have a way of dissecting the layers for you. And we have a thing called BOGO MIPS, which goes out there and measures the capacity of the machine, just CPU only. So we look at the CPU, then we look at the client-server experience from a local host standpoint, from a remote client standpoint, and from a loopback client standpoint. And if you can dissect all of those numbers, it's very easy to see, is it a network problem, or is it my setup problem, or is it a general problem? Because if they're all slow, it's a general problem. If only the client server with the remote client is slow, then it's the network. If it's the loopback and the client server, it could be my setup again. So it's very important to understand that. We're only at 20% utilization. Of what? Are you only at 20% utilization of memory? Well, allocate more of it, because you're going to use that memory, and that's going to be effective to get it better performance. SAN storage is better. SAN storage is always worse than local storage. Direct connect storage will always outperform it because there's no latency or there's limited latency. And people are spending all this money on SANs. If you need the features of a SAN, then it's a perfectly reasonable thing to do. But realize you're doing that in exchange for performance. So if your number 1, 2, and 3 goals are performance, then a SAN is not where you want to be. You want to be in direct storage. This performance slide is the one, nothing has changed. I asked this question, what's changed? And they go, nothing. So then I start asking questions that I know have changed. Has the date changed? And people go, oh yeah, the date's changed. Well, yesterday was the 29th of the month, this is the 30th of the month, or worse yet, this is the 30th of the month and today's the 1st of the month, and you're looking at a month's worth of data. If I was looking through the whole month's worth of data, it took a long, long time to do that. If I'm only looking through 1 day of data, it works really, really fast. So it might be something as simple as the date changing, and that range that you're looking at is so much smaller now than it was before, or larger than it was before. But I went out to a site and they said nothing had changed. And we went out there and tore through the system, did all sorts of performance work, and we looked at it and we found, wow, there's this one table that's getting read a lot. And I mean a lot, billions of times a day. And we said, you sure nothing changed? And they said, no, nothing's changed at all. Oh, we did drop an index. And they just happened to drop the index that that table was using for every query that it was doing. And when we went back and put the index back in there, lo and behold, the performance was much better. So you have to find out all the changes that happen on your system, but you also, in now environments where you're in virtualized environments, you have to find out what else has happened on the frame you're on. If you're sharing storage with other people, you need to know what those other people are doing. I've had performance problems on Progress applications because PeopleSoft Financials is running its month end. Last I knew, nothing in Progress is PeopleSoft. So how did PeopleSoft affect it? They were using different LUNs on the same storage as the Progress application. So the PeopleSoft, whenever it ran its month end, performance on their Progress database was horrible. So we imaged that storage so those two were divided. And then PeopleSoft had its own storage and it could be crummy when it needed to be, and Progress just stayed good because it never had to compete with PeopleSoft. So make sure that you understand what's happening on your system and all the systems that are tightly coupled with you. And that tightly coupled might not be that tightly coupled when you're talking about the network. It might be something very, very different on the network. So that's an important thing. Components of performance. Application, really the first 3 should be application, and then anything else. Because application performance is absolutely the most important thing. If you're not utilizing indexes, you're not doing things as efficiently as possible, that you're doing multiple deletes rather than batching them up, you're doing things that are not, not proper, you're going to hit performance problems regardless of how much hardware, how much smarts you throw at the problem. You have to solve those problems first. But we'll talk about the hardware, OpenEdge, and other. And most people don't think of the other category, but we'll talk a little bit about that. It's the largest component of application performance, or of performance for your system, is the application. And if you can get good application performance, you'll be able to scale very, very well. I did a tuning engagement a long time ago, and we found one thing that we had to fix, and we went from being able to scale to 2,000 users to being able to scale to 15,000 users. We changed one program. So it's very, very interesting what you can do. It might be that it's one key program that does it. It might be a selection of them. But it's generally not hundreds of programs that you have to look at. It's generally just a few that you can make a big, big splash with. Hardware. Going from slowest to fastest, we have network performance that we need to look at. We have disk storage. And so I say disk. I used to always say disk, and now I more say storage because we're not buying disks anymore. We're buying SSDs, which are solid state. It is 2019. If you're buying new hardware now and it's not solid state, you're buying the wrong thing. You're absolutely buying the wrong thing. Memory, we want to make sure that we have enough memory to be able to satisfy our buffer requirements, also any user requirements out there, but we want to be able to take advantage of secondary buffer pools or an alternate buffer pool, because that can provide a huge relief for the performance of the buffer pool. And the way that works is it eliminates the amount of work that has to do. If I fully allocate a table into the secondary buffer pool and it's totally held by memory, I can read that, and I don't have to do any latching to get that. I can just read through that table very, very quickly, and its latching is not affecting other users. So it goes faster, and it helps everybody else as well. This is the lie. It's never the network. The idea that you need to worry about as the administrator is that you need to make sure that any data-intensive work is getting done closer to the database engine. And what you want to do is, if you have complex queries, those get executed at the database engine. That can be done in two ways. One, you can have a report server that you have, and it launches it, and it launches the thing as a batch process on the database engine itself. The other thing you can do is have app servers. App servers can do all the heavy lifting. They can be located with the database, and then they feed back to the clients. And instead of having to go out there and do a query and have lots of the queries satisfied, like if I go look for an average, I'd have to go back and grab all those records to satisfy that average if I'm in client-server mode. If I do that in an app server, it'll figure out the average and only send the value of the average across the network. So therefore, I save myself thousands and thousands of packets, and I get the answer much faster. So I have lightened the load on the network for everybody. So we're trying to push things off of the network wherever we can. And that's really the goal for all of these resources. We're trying to push the performance bottleneck to the fastest resource we can get it on. So when we're on network, we want to get things off the network, and that might mean that we do additional disk I/O. When we go to the disk and storage, we want to say, SAN storage is better? No, it's not. There's greater latency between the SAN storage and what we're doing. So if we can go to local host-based, or we can have something that's inside the rack, it's going to be much, much faster. This is where you should spend your money most wisely, because this should be where you spend the bulk of your money. CPUs are free now, or just about free. The things that are expensive is all of these fast I/O cabinets that we're buying. We have a client that has 2 Fusion I/O cards mirrored. Like one Fusion I/O card wasn't fast enough. But their I/O, they never have I/O over 1 millisecond. So it's very, very fast. We should be using SSD everywhere we can. If you need the specific feature, if you need to use something like clustering, and you need a SAN for that, that's a perfectly valid reason to have one. But if you're just doing it because, little Johnny Mulligan across the street's got a SAN, that's not the right answer. You want to make sure that you're using the features that are there, and if you're using features that you need, that's great. If you're not, then it's just a waste of performance. Absolutely no NetApp filers. NetApp filers are file-based. Progress is block-based. The two don't ever meet, and your performance will be majestic. That's a way of saying it will be horrible. Memory. Think about memory as being used to eliminate disk I/O. So can I get stuff up into memory that I read it once into memory, or read it infrequently into memory, and many people can use it? And that's why getting a high enough buffer pool, you want your buffer hit rate to be as high as possible. Most of our clients are in the 99% range now. We do about 99% buffer hit rate. I have one client, if we did 98% buffer hit rate, I think their storage cabinet would glow red, because there's so much I/O going on. So these little percentages mean a huge amount. If you go from 98% to 99%, you've eliminated 50% of the I/O on the system by a 1% change. So that change is huge. So trying to achieve the highest buffer hit rate you can, and if you're not getting 95% buffer hit rate, you've got some other issue that we need to look at. Got some other issue maybe in the application that needs to be looked at because we can't solve it by creating a bigger buffer pool. We can't get that out there. But don't forget to use minus B2, and this parameter here, LRU skips, you should have set on every database. And it allows Progress to look through the LRU table more efficiently. And it doesn't need to be set high, it just needs to be set. Minus B2 is the alternate buffer pool, and the alternate buffer pool allows you to cache static tables that are mostly static, and generally one size. So I have the static size of them. There might be, but they're rapidly read. Think about like state table or zip codes or your bill materials or something like that. Something that you read through millions of times a day or billions of times a day that doesn't grow or shrink very much over time. You can put that into the B2 and you can eliminate all of the LRU activity associated with that as long as you can fully allocate memory to accommodate it. So remember, you have to accommodate both the table and its indexes. Don't think of just the table itself. This is the best way to use it. It's fully store objects, data objects in memory. If you're looking through indexes, you could just put the index out there, but most people are looking at indexes and data, so you want to have enough for everything out there. The rapidly read is the key word here, rapidly read and statically sized. If they're not statically sized, then what will happen is over time it'll grow and get beyond the bounds of B2, and then it'll start doing LRU activity in the B2, which you were trying to avoid in the first place. So make sure that either you're monitoring it and that you're going to get ahead of this. All of these slides are going to be on the website after this, so you don't have to, you can take pictures of them, but you don't need to. But the best, these are the ones that I care about most. You want to have those rapidly read, like the state, those kind of tables that you can put out there, because you'll read them once in there, they'll be resident in memory, and every other I/O of that will not only eliminate the I/O to disk, it will also eliminate all of the LRU activity with that, which becomes very significant on things that get read billions of times a day. So that's what we want to do. And you need to calculate the storage of the table, its associated index, and then add some padding factor. My padding factor is generally like 20%, something fairly large, so you know you're right. You don't want to be almost right on this. This is one of these ones that it's not like a hand grenade. You're not going to be close enough. You have to be all the way there, and it'll work. So make sure that you give it well more. You have to tell it in the meta schema that it's going to be a B2 table. So you tell it that it goes in there, and then the first person who reads it, when they read it, it goes into the B2.
Yeah, but when I start the database, there's no utility to put them into B2.
Oh, they will not, it does not auto-populate the table into B2. What it'll do is it'll wait for it to get a request.
So first few requests will be slow.
The first, yes. Yeah. Well, it doesn't change between the B or the B2. The only way that anything gets into the buffer pool is I request it. The first people always get punished. And the punishment...
Yeah, but then I cannot guarantee that even performance, even I have.
Well, what I can do is I can guarantee performance all I want, because I can just say, in my startup routine, I'll have my populate b2.p that goes out there and reads the B2 for me. No user will ever have to get it. It's when I start the database, I run populate b2.p, and it reads that table in full into B2. Then everybody else will get cheap reads for the rest of the time that the database is up. So I can guarantee that same performance all through the day. And again, that's, you're trying to become someone who is providing that service where it's just it works the same every time. Whether it's busy or slow, the same performance to the users is provided. And that's, you can do that very easily by doing what I just said of pre-populating that B2 with a program.
I mean, I was expecting no database parameter minus populate B2 or something.
It's a great feature. And Rich is on that right now. He has to worry about 5 nines. He can't worry about any of this populate B2. You can write populate B2 .p yourself. CPUs, this is where we see most people make the biggest mistakes. What they do is they go out there and they buy maximum number of cores. That's not the best policy. Maximum number of cores leads to 2 potential problems. First is the cache coherency problem. If I've got 36 CPUs out there, I buy 2 Xeon 18 core processors, and I've got 36 CPUs out there. When I do requests, I have to check the cache of every other core. So that cache coherency has to be checked. So that causes a lot of overhead out there. And it's the only way that we can guarantee referential integrity of that data that we do that. So there's no workaround for that. It just works that way. So if you have fewer, faster cores, it's going to do that cache coherency check much, much faster and provide much less system I/O or system overhead. The next problem that you hit when you try to get maximum cores is what I call the NUMA problem. NUMA, there's a lot of manufacturers out there that have machines that are NUMA machines, and that's non-uniform memory access machines. And how they work is slightly differently than an SMP machine. You have individual machines that are tightly coupled inside the bigger box. And I have a picture that'll show this better, but there are things called near and far memory reads. Near memory is the memory that's in the same block as I'm in, and far memory is in any other block inside the machine. It costs 3 times as much to read far memory as near memory. And people don't start seeing this problem until they start scaling. So as they add more users, then the necessity to use another block in the NUMA is higher, or cell. You use another cell in the NUMA. So performance might be great for a while, then you add the 101st user, and then it becomes variable for everybody. And it's really, really frustrating. It's really hard to capture. So NUMA is a no-no for progress. If you have NUMA machines, there are ways of circumventing the natural affinity of it to want to spread things out. And we could talk about that separately if you have a NUMA machine. So NUMA has the far memory. The big thing is we've had clients who've gone out and they've done benchmark testing on the second biggest machine that the vendor has. That second biggest machine is an SMP machine. The biggest machine is a NUMA machine. So they go and they say, well, that's good, so little's got to be good. I have to have a lot. I call it the aspirin principle. If one's going to work, then taking 10 is probably a better idea. So they've gone out, they've tested this, and then all of a sudden they're in a totally different memory access model, and the performance becomes variable for them, and they don't know why, because they bought a bigger box, but the bigger box isn't SMP. So when you talk to vendors, if you see high core counts, you need to ask, is this box NUMA or is it SMP? And you need to hear the right answer. It needs to be SMP for progress to perform as best. So this goal here is buy the fastest chips with the fewest cores per socket that you can. So I buy Xeon processors, and it's amazing. You go to Dell's website, they have this huge list of CPUs there, and right down at the bottom there's the one that is, a gigahertz faster and has 4 cores in it. Those are the ones I like. Those are the ones I want to have, because 4 cores, I buy 2 of those, I got 8 cores, it'll handle almost anybody's thing in the world. If you've got 16 or 24 cores right now, most likely you have too many cores. And you'd be better off having smaller, less cores, and your performance would be better with less cores. Much better. Yes?
Is it never been on almost like 4 and 6 cores?
Is it never on 4 and 6 cores? No. It can be on 4 and 6 cores. It's very unlikely. It's more likely that you'd be on a VM of 6 cores, and that VM was sitting on a NUMA box that had many, many cores. But the 6 cores, if it only had 6 cores, I would say you would have a 99.9% chance that it's going to be an SMP box, because you have to kind of get into a lot of things. But HP is the outlier here because they have very low core counts. So you can become NUMA very, very quickly with very few cores on HP. So that's the one you watch. But basically, this is what a NUMA box looks like inside, is that you've got cores and memory that are tightly coupled here. And reading from here to here is no problem. Anytime I have to go across to here, I have to go across this high-speed interconnect. And that's where I get the 3 times worse performance. So it costs me 3 times as much to get the same, to get one memory address over here. And the worst part is, if you're looking for a big piece of shared memory, it might be thousands of those reads that are 3 times as slow, and then it becomes a very, you can see the problem, it's obvious. And there's a way to say don't cross over lines, but you have to make sure that you only use the amount of memory that's in this rack and the number of cores that are in this cell. But you can do that at a software level. You can tell it to do that, and that can kind of break the NUMA apart into multiple logical machines, and it works relatively well. Or better than using the NUMA in its natural state. Tom was looking at me, giving me the hairy eyeball when I gave that. But it does work better. It's just not ideal. Yeah. So the Progress OpenEdge database, we want to talk about using everybody should be on type 2 storage now because it's universally faster for everybody. We've tested all kinds of different workloads on that, and we haven't found anybody, and I'm waiting for the day that somebody proves me wrong, but I don't think it'll ever come, that type 1 storage is faster for something, but we haven't found that it's faster for anything. So get everything into type 2 storage area. Type 2 storage area is clustered storage, so you get a couple benefits there. You reduce the amount of scatter of the records because they're all clustered together in a block or in a group of blocks. And then you also, when the data is being read from disk, the proximity of the next block is likely to be in that block that you're reading. So what happens is I get optimistic read, and most of these vendors have this optimistic read ahead, and all they do is they just read the next block thinking that you might want it. And lo and behold, on type 2, that happens a lot. So you get a benefit of having stuff that's been pre-read into memory, pre-read into the cache for you, so you get a cheap read on the next one. Then we talk about the data access models about host-based. Host-based would be the fastest because everybody's really tightly coupled to the database. You have both the clients and the server sitting on one machine, so all my access would come through shared memory. Some people circumvent this by putting in the -S and -H on their clients that are local. Well, we call that a loopback client, and they sit there and go through and do all the overhead for client server when they don't need to, and they go through a server process. So there's a lot of overhead that you're adding for no apparent gain. So it's not.
The chances of database shutdown are much higher in that model compared to this one.
I don't buy that anymore. I think you're talking old progress, not new progress. There still is a chance that you could have a user go and it could take the whole database down. Yes, you could have a shared memory issue where that person had some vital resource. But that's being looked at even now as something that they're going to be able to get around, because a lot of the things are going to be made read-only, which are going to be able to allow them to be released. So even if a user were to go away with a bad signal, like a kill -9, the vast majority of times it will be able to just release that and do that. But the problem is so small right now. I have clients who do this who have thousands of clients. They have thousands of users on their system, and they're all host-based users, and they see not once per year that they have a shared memory issue. But they're current. They're on 11.7. So it's very rare, as long as your administrators have some discipline and don't do kill -9, and your users have relatively some discipline and don't X out of their Windows session or whatever. Those are the things that tend to sweep it away, but it's still fairly rare, and the benefit far, far outweighs the cost. So, it just is much better to do that. Client server, great if you need to have graphical user interface, all of that kind of stuff. And then end tier with app server. This is where I think that most people are going to end up because it's kind of the best of both worlds. I can have a really snazzy interface and I can have my complex queries all done local to the database. And so I'm getting kind of the best of both worlds that way. Type 2 storage, universally faster than Type 1. The data is clustered together. Initially, index blocks were antisocial. They would always have all entries from one index sitting inside a block. What Type 2 has done is that said, we're going to do that for all the data objects out there. So records now are tightly grouped, and you can have 8, 64, or 512 blocks in a cluster. And that means that you could have 512 8K blocks sitting right side by each with only storing data from one table. And that would mean that you would probably get a lot of benefit from the optimistic read ahead that your fast storage is doing. So that gives you a big benefit there. It will reduce scatter over time. It won't get scattered as quickly. It doesn't completely eliminate the need for reorganization every so often. Whether that reorganization is a dump and load, or whether it's a table move, or whether it's something else. But it's going to be disruptive no matter what you have to do to get that reorganized. But it happens much less frequently and on Type 2 than it does on Type 1. Host base, we like that because everybody lives there, but we do run the risk of having a user getting killed and taking away the database server. But I still think that that risk is fairly low. And if I have disciplined database and system administrators, it becomes acceptable. So it's not zero, but it's near enough to zero that it's acceptable. It's generally going to perform the best of all the solutions. It's not generally, because everything's right next to each other. So there's no latency, there's no network traffic, there's no having to pack it up anything. It just goes straight. The client reads shared memory directly, comes to it, it can do it once, and then off it goes. So it's much, much faster. And host-based clients should be used for all your reporting and any other bulk operations you're doing. They should be done locally. Even if the clients are client-server clients, they should have some sort of report writer or something else that they can put their request into, and then it gets executed on the server side, because that'll increase performance and reduce network overhead for everybody else. Client-server data access is through a server. So you have, when I start the database, I don't start a server, even though I say ProServe. I start a broker. The broker goes out there, and that does that allocation of memory. Local clients can directly access that memory. So they're direct access clients. They go out and read the shared memory directly. They update latches directly. They do everything they need to do. Client-server users, they have to come through and have an agent local to the database to be able to read that memory. So what they do is they go through a server process. That server process is a queued first in, first out server process that reads the records that they need. There's overhead with that because the records have to be extracted, packeted up, and then shipped across the wire. And the things that you need to do to improve the performance of that is you need to increase the packet sizes that you're sending with the -mm. You need to set that larger. The default is woefully inadequate. So we want it to be much, much larger. We like 16 meg or something like that, or 16K packets to go. I'd like 16 meg packets, but 16K packets to go across. But you need to also, that's going to affect your network environment. You need to make sure that you have, that you've set up for large packets out there. Otherwise, it's just going to get broken up at some other place. So it doesn't give you all the benefit that you can get. And complex queries, and it's not even that complex. All I have to do is ask for an average. That's going to get punished over client server versus asking for an average locally. So that's the thing that we need to worry about with client server. How we can solve that in a different way, we can allow the clients to make the same queries that they have, but they ask the app server to do the work for them. Then the app server can go gather all those records, do what it has to do, and then ship it down the wire. But don't complicate things by putting your app servers on a separate machine, People go out there and they go, oh, I got all this performance. I'm going to go put my app servers on one machine. I'm going to have my database server here, and I'm going to have my clients over here. Well, sounds great, but the biggest benefit that you're getting from that app server is that you're reducing network traffic. And the network traffic isn't going to be reduced if it has to go across there to get to the app server. So put the app server processes on the same box. We have clients where, one second. We have clients who have to scale very large, who need to have this spread out. And they do have to do that because they can't get enough capacity on a single node to be able to support all their app servers. So what they do is, in that case, you do like a hybrid app server approach where you have the very, very high volume app servers, where you say, I'm going to send crummy query.p to app server 1, okay? App server 1 will reside locally to the database. But then I've got efficient query 2, it can go to one that's sitting on another machine. And that way, you can kind of get the best of both worlds that way. So it allows you to scale very, very large into, when you have tens of thousands of users or 5,000 or more users, you may not be able to buy enough single machine capacity to support the database engine and all the app servers for that. So doing it in that way where you set some local and some away is a good way of doing that. And you'll find out that there's going to be a very small subset that have those really crummy queries that you need to put locally. And so just being intelligent in your app server setup can save you tons and tons of network traffic over the wire. And what was your, did I make your point? Or
Same thing.
okay.
I was saying it impacts scalability, putting
Yeah, his point is that, I'm repeating it for the microphone, is that you impede scalability of your application if you can only go to a single machine. But again, I try to say go to multi-machine, but do it intelligently on how you do that. This is when you have the bad application. I've got the application, I know the code's not as good as it could be, I know it's not as efficient as it could be, and there are certain things that we do every day. And I had a client that they ran a report every day, and it created a report like this big in paper. And I said, I wonder if anyone's reading that report. So what I did was, every day I had the operations people not run the report. And I ran just a header page. And I had them put that on top of the ream of paper, just the header page, every day. I got a call from them 4 months later that they weren't running the report. And I said, you don't need to run it. You need to run it once every 4 months. You don't need to run it once every day. So it's very important that you understand what the real need is. People will say, I need this every day, but are they really using it every day? And if they are, fine. You might need to just take that report and move it off hours. So if you're 3 shifts, that's hard to do. But most people aren't 3 shifts. Most people are 2 shifts or 1 shift. And if you could do that, you could say, oh, you need that crummy report.p run every day. Great, I'm going to run that, but I'm going to run it at 2 in the morning when no one's here. And that way, you're not affecting performance for everybody else. The other thing is when you do things like shift change, where they have to have the work assignments for all the workers for the next shift, make sure that those are run before they get on, as far before as your operations will allow. That way, there won't be this big changeover in users and report running all at the same time. The reports will run just before they get in, then all the users will have all the logouts and logins, and it will make performance much more uniform across there. So it's just thinking about who those are. People are really important. Yeah, thanks. People are really important in this whole process, because everybody has that canary in their office. And they used to take canaries and bring them down in the coal mines. If the canary fell over, then they would go, we got to get out of here. Sometimes it worked, and sometimes it didn't. But your site has the canary, the person who's going to fall over before everybody else does. So what you need to do is make sure that you're very attuned to that person, and when they start getting agitated, then find out what's going on in the system. And that can be done through monitoring, and that can be done through knowing how your application runs throughout the day. Operations, moving things to off hours, question everything that generates a lot of paper, because people don't read a lot of paper ever. Canaries. There's whiners are people who just complain all the time. Yeah, we're only getting 10,000 transactions a second. That's horrible. Well, you know what? Live with it. Those people you can just ignore. But the people who are good advocates are invaluable, and they're on the system and know what's going on much more clearly than you do. You don't understand stuff because you're sitting in operations, and a lot of times you're just looking at numbers come by. You're not looking at the actual throughput of the system. It's actual working. And these people can do that. So collaborate with your users and find out who the people you need to keep in contact with. Policies. Ad hoc reports must be run off your replica server. Nothing can be run in production. Reports must run through a report queue so I can throttle the number of running reports at the given time. And all programs must go through performance review. Everybody loves this. Programmers really love this because there's going to be someone sitting there going, no, that's not good enough. But it's a good policy to have everybody's code looked at by somebody else. So you're not just putting something into code without it getting looked at by another set of eyes. Understand your workload. This is where we can come in and help with ProTop. You can use ProTop, and it's a shameless plug for my company, but it is free to try, so please try it. But there is OpenEdge management, or you can write your own VST code. It's important to understand where your peak volumes are. Are your peak volumes during business hours where people are affected, or are they off hours? If they're off hours, I don't really care about that too much because it's just the system's busy and who cares? As long as I'm making my time critical stuff get through. So if I have an MRP run that needs to be done before the 6 a.m. shift and it's getting done at 5:45, I'm worried. I want it to be done at 5 or earlier. So we need to make sure that we understand what is affecting those things. The things that you need to look at are the total number of requests and reads that you're doing, so you know how much logical and physical I/O you're doing out there. The top N tables. A lot of times by just looking at the tables, you'll find out something new. And this happens all the time. We go out there and go, I didn't know we used that table. And we're reading it 4 times as much as any other table out there. And it's because some piece of code that no one thought about got put into production, and it just got worse and worse over time. So look at that. Look at your top N index requests as well to make sure that those indexes are, well suited for the queries that you're doing. Commits are some other update metric that matters to you. You might find out that you have something in your application of how many widgets you create per hour. That's a great metric. It doesn't have to be just a VST metric, but ours is more generic, so it has to be a generic VST metric, and we use transactions and commits. And then focus on production times. When humans are affected by performance, don't think about the times where no one's there, because it doesn't matter. Okay, these are the couple of case studies, and I'll go through them pretty quickly. But if I've got massive reporting out there, what I want to do is I want to make sure that there's reporting happening throughout the day. What my options are, I have options that are, I can go and run offline reporting database. That might be hard to keep up and maintain if your data is very large. I might be able to do a replication database used for reporting. That's good, but it costs money because I have to buy replication. Or I can buy greater capacity and just live with the load that I have now. So all of those are options for you, but you have to look at all the options to figure out which one's going to work best for you. And, and this one is kind of the buy the bigger hammer, is buy greater capacity. This is a buy a bigger hammer, so I'm actually lying to you right now that that's a good idea. But it is an idea, it's just not a good one. So compute-intensive applications, a lot of applications like mortgage applications do tons and tons of calculations. So you might have one machine that had really good data access as your database engine, and then you offload all of those statistical query stuff off to some other compute hardware that's much cheaper to buy. So you could have Linux servers with running out there that are doing all that calculation stuff and then feeding the data back to the user. So this is a really good example of mortgage applications. And they generally are that kind of hybrid environment where they have stuff that's local and then stuff that's remote, and then they have compute-intensive stuff and data-intensive stuff. And then the rapid reader table. This is that table you go through all the time, every day. The B2 and LRU2 skips, if you do everything right, you'll never use LRU2 skips. But set it anyway because you could be wrong. I've been wrong once. Just once, though. Yeah. But make sure that you have type 2 storage, you're using LRU skips for the database buffer pool, and then LRU2 skips for the secondary buffer pool. And then what you're going to do is take that single small table, or it doesn't even have to be that small, it's just a single sized table, and put that up into the alternate buffer pool and allow people to read from there. You'll save lots of resources for everybody, and that's really what you want to do. Watch out for common lies. The network is only 10% busy. Let's buy 18-core CPUs. We need a SAN. Nothing has changed. Look out for all of those things. Let your users help you find the pain points. They're usually very, very amenable to this situation. They want to tell you. So use the ones that are not whiners, but good system advocates to help you do that. And performance is a product of good application coding and good operations and hardware. If you have all of that, you will have excellent performance and excellent scalability. Any questions? Comments? Personal problems? Recommendation for spin? It depends. 2 to 10,000. Somewhere between 2 and 10,000 we found works good for most people. There are exceptions on some really weird hardware, but most people don't have that. Most people, if they set it between 2 and 10,000, they're going to be right. That's the 90-10 rule, at least. Any other question?
So what's the theory behind this more CPUs, less performance?
More CPU, more cores means that there's more coherency checking. So I have more system overhead there. And generally, as the chip count increases, the chip speed decreases. And Progress has lots of parts that are still single-threaded in there, so having the fastest individual cores is the best policy.
Is it applicable to IBM?
It's applicable to IBM. It's applicable. It's a matter of fact how chips work. It's not a matter of fact how Progress works. It's not a matter of fact of how anything works. It's how chips work. Yeah, absolutely. And if you find anything or have a question, I'm happy to answer. And my email is on the next slide. Okay. Yeah, and we found cases where people reduce CPU and the performance goes way up, and it scares you when it happens. You're like, wow, I've been wasting all this CPU for all these years. Okay, thank you very much. Anyone has any questions, I'll be around. You can ask questions. Thank you so much for your time. I appreciate it.